This is the tutorial for driving multiple LEDs. Let's go.
This is the basic code for driving multiple LEDs. In this code, we're going to use 6 different codes to make 6 different LEDs dance and light up in different variations on the Arduino board. First, we're going to use integer LED pins to define the pins that the LEDs are connected to on the circuit board, 4, 5, 6, 7, 8, and 9. In board setup, we're we're defining variables to store the index for which the pins we want to control. So for the integer index, we're going to start defining it as 0, so start at 0, and then for numbers that are less than or equal to 5, the code will run, and the index plus plus means it's just going to add 1 to it after each run through. So then in void loop here we have 6 codes that are right now they're commented out, so the computer isn't reading it as code using these double slashes, but if we delete them it turns into code. For right now we're not going to do that. So the first code is one after another, no loop, and this is program 1, so it's going to light up each of the LEDs in turn and then turn them off in reverse. And then the second code is going to be the same lighting situation as the first, but it's going to use different code using the index. Third code, one at a time, is it's going to turn each LED on and then off in succession, looping to all the LEDs and back. Program number 4, ping pong, it's going to be like a tennis match. It's going to do different ones. Marquee is program number 5. It's going to do them in different variations, similar to how we see LED boards for signs. Random LED is going to use the index to choose random LEDs to light up. So in order to use any of these codes, we just delete the 2 slash marks and it will make it code, and we can do it to one of them or all of them or a couple of them, and it will run all of them in order in a loop. So program 1, so avoid one after another loop is the name of the code kind of, it's gonna have all the code go on underneath. So here is integer delay time is 100, so it's 100 milliseconds. It's going to be a pause in between the LEDs. And so this code here is going to turn all the LEDs on. So for LED pin 0, which is going to be the first LED, it's turn on high, and then delay time is just going to wait until it gets turned off. So it's, number 0 is pin 4, and so going up to 5 is pin number 9. And so we can turn pin 1 on, number 1 on, same thing, all the way 1, 2, 3, 4, and 5. And then we're going to turn them off in reverse. So starting with 5, we go turn on low power, so that's off. And then wait and turn on 4 to low power and off. 3, 2, 1, 0. So that's all 6 LEDs. And that's just this little thing here, that's going to loop all the way through unless there's another code opened. So we're going to stop that. We're going to show you the code.
So this is the Arduino board. Right now program 1 is running on it for the code. This black wire here is connecting the ground to all the cathodes of the LEDs by plugging into the negative column here, which all of the LEDs are connected to. Then each of these LEDs are connected with a 100 ohm resistor on each of them. And then they're also connected to each different pins for power or the information coming from the code. So this one here is connected to pin 4 through the orange wire, all the way here. Next one's pin 5, pin 6, 7, 8, 9, all the way up to 9. So each of these LEDs is connected to a separate pin. This is also running program 1, so we see the code working for that. So for program number 2, we gotta delete the 2 slashes to turn it on into code. Going down to program number 2, it's going to do the exact same thing as the first code, but we're taking advantage of the loops, the for loops we defined up top, and then array it so we don't have to do as much typing. So integer index, we're using the index that we defined up here. Delay time 100 milliseconds, so that's going to be paused between each of the LEDs. So then we're going to turn all the LEDs on in order to do this. So the for index, defining it starting at 0, so that 0 is the first LED. So less than and greater than 5, this code will run. And then for each one, it's going to add 1 to it, so counting up from 0 to 5. So then we're going to use digital write LED pin index high. So using the digital write, it's going to take the number that is in the index, 0 through 5, and turn it on, and then delay, so it's going to stay on until it gets the code to turn it off. And that's going to loop all the way through 5. And then we're going to turn all the LEDs off, so for when the index equals 5, that's the start. And then then it's going to, any number that is greater than or equal to 0, the code's going to run, and then it's going to minus the index minus is going to subtract 1 from it each time. So using digital write LED pin index low, it's going to turn each of the numbers that is inside this index here to low power or off, and then delay time until it's off. And then these little things is the end of the code. And then that's it. I'm going to show you the code for that. Same wiring. This is just program 2 running on the LEDs. So for code number 3, we're going to delete the 2 slashes again to turn the comment into code. Go down to number 3. So void 1 at a time. It's the code that we're going to be doing now. So using the integer index again and delaying the time to 100 milliseconds, pause between the LEDs. And we're going to use this for index code again to step through the LEDs from 0 to 5. So we're going to start off defining index at 0, and using the index less than or equal to 5, it's going to run the code right here below. And then index plus plus means for each run through, it's going to add 1 to it. So once this is done all the way through, it's going to add the next number. So going from 0, 1, 2, 3, 4, 5. So first thing is, using digital write LED pin index high is going to turn the pin that is inside this index here to high, so turning the LED on. Delay time is pausing the LED to slow it down a little bit. And then using digital write LED pin index low is turning that same number to low power, which is turning the LED off. And that's closing there, and it's going to end there. This is program 3 running on the LEDs. Nothing else has changed with the wiring. This is the code for program number 4, ping pong. So this code is going to turn the lights on in a succession, and it's going to look like it's bouncing from the first LED to the last. So again, the code. So into the index, so using the index again, using a delay time of 100 milliseconds between each LED again. And then so using the for index code, we're going to again define index as 0, and then for numbers that are less than or equal to 5, this code will run, and then for each run through, it's going to add 1 to it. So digital write LED pin index high. So it's going to turn that LED on and the index to on. It's going to delay time again to slow down, and then it's going to turn the LED off using digital write LED pin index low. That's going to run through 0 through 5, and then we're going to step from LEDs 5 to 0. So using the for index formula, we're going to define the index as 5 using numbers that are greater than or equal to 0, so counting down from 5. this code here is going to run, and then through each run it's going to minus 1 from 5, or the number before it. So going 5, 4, 3, 2, 1, using minus minus. Digital right LED pin index high. We'll turn the LED on. It's going to delay till, and then it's going to turn it off using digital right LED pin index low. And then that's the code. It's going to loop all the way through. Here's program 4 running through the LEDs. So for program number 5, we're going to turn it into code again from the comments. Go down to program number 5, marquee. So it's going to mimic similar ways we see in signs and movie posters and stuff like that. So using the index integer again and delay, but this time we're going to do a 200 millisecond delay time. It's going to be a little longer pause in between LEDs and just a little more choppier how we see it. What it's going to do is going to light up. It's going to basically split the LEDs into 2 groups, the first 3 and the second 3 LEDs. And it's going to turn on the first one and the fourth one at the same time, and the second and the fifth and the third and the sixth. So for index, we're defining index is 0 again, and as for index, for numbers less than equal to 2, this code is going to run, and then it's going to add 1 to each time. So for index, it's going to turn on high, that first LED on, and then it's going to add 3 to it, so that is going to basically jump to the next grouping of LEDs. So it's going to skip to the first LED, it's going to skip to the fourth LED, turning that on as well. It's going to delay there, and it's going to turn the same first LED off, and then the same second LED off. And it's going to run through all the LEDs, and it can stay in a loop. Here's program 5, running through the LEDs. So we're going to turn the program 6 on into code, so we can use it for our board. And then, so program 6, we're doing turning on a random LED at a random time. So using the index again, we're delaying the time, so it's gonna use a random number for each time it's called. So index equals random 6. So it's going to pick a random LED, and we're using 6 because the random code does not register 0 as a placeholder. So in order to get all the LEDs in, we have to use 1 through 6. So once that picks a random number in the index, then it's going to delay time for 100 milliseconds, and then digital right LED pin index high is going to turn that until it turns off, which will be soonly after. So digital right LED pin index low, which turns the LED off, and that's going to repeat for a loop. Here's program 6, turning on random LEDs. Here is all of 6 of the codes turned on and running through in order, going through program 1, 2, 3, 4, 5, and 6 in order that is written in the code. So we'll run through one more time. There we go.
This is the code for driving multiple LEDs modified. So first, we're defining the LED pins 6, 7, 8, 9. That's the pins the 4 LEDs that are connected to. Also, in this code, I'm having 4 LEDs, a red, a yellow, a green, and a blue, be lit up randomly, and an RGB LED will also turn it on. That it's going to correspond to the colors to the same normal LED that gets turned on. So that's all the LEDs, and then this is creating constant integers For the red pin, green pins, and blue pins that the RGB LED is connected to. So the red is connected to pin 5, green is connected to pin 4, and blue pin is connected to pin 3. Okay. In void setup, we're creating local variables to store the index. So for when the index equals 0, we're starting that off. And then for numbers, the index is going to less than or equal to 3. The code is going to follow. And then index plus plus, for every run through, 1 is going to be added to it. Then we're defining, this is the LED pin index as an output. So the information or power is going to go to those. So this is that pin. And then we're also defining the pins in the RGB LED as outputs. Red pin output, green pin output, and blue pin output. Also here's the serial begin 9600. That's opening the serial port for the code. In void loop, starting with the integer index and delay time, so that's just going to pause it. And then index equals random 4, so it's going to pick a random LED between of the LEDs, and it's 4 because it doesn't register 0 as a number, so we got to do 1 through 4. We're delaying time for 100 milliseconds here. And then here is what's going to determine the color of the RGB LED. So if index equals 3, then the code will follow. So it's going to turn on the red pin of the RGB LED. So digital write pin, red pin high is going to turn that on, and then digital write green pin low and digital write blue pin low is going to turn those both off, or just not turn them on. So it's turning that on, turning the color red on at the same time as, since 3 is the position of the red LED on the board, the reds will both turn on. If index equals number 2, then the RGB LED will turn on yellow because 2 is the position of the yellow LED. So the red pin will turn on high, the green pin will turn on high, turning them both on, and the blue pin will be turned off. Here and then serial print on yellow, so it's going to tell us up here if the yellow is on. If index equals 1, then the green LED will turn on, so that because that's the position of the green LED. So that's going to turn the digital red pin low, so the red is going to be off. Digital write green pin high is going to turn the green pin on. Digital write blue pin low is going to turn blue pin off. So just the green is going to be turned on, and this serial print ln is going to be the new saying is the green's on. So and then lastly, if index equals 0, which is the position of the blue LED, then the blue RGB LED will turn on. So red pin will be on low, green pin will be on low, and blue pin will be on high, turning just the blue on. And then we're just printing blue again in the serial print. And then once you have that defined, using the index, digital write LED bin index high, so it's going to turn on the number in the index to on. So that's going to use this code also to turn on the RGB LED. We're going to wait for 500 milliseconds or half a second. That's going to print on, and then we're going to turn the index, the LED pin of that index number off, or low power means off, and then we're just going to print off, and then that's the code. And well, for that, which is the serial monitor. So on off blue, it's going to show what's going on the board. So that's it.
This is the code for driving multiple LEDs modified. First we have this black wire here that is connected to the ground, and it's connected to the negative column here, and that's connecting all the cathodes of the LEDs, these 4 LEDs, to ground. Then we have, for the red LED, and red, yellow, green, and blue LEDs, we have 100 ohm resistors, and then they're connected through their wires. So the red one is to power or the information. So the red LED is connected through this wire here into pin number 9. Let's see. And then the yellow LED is connected from this wire here all the way into pin number 8. And then the green LED is this wire here. It's connected to pin number, let's see, pin number 7. And then the blue LED through this wire here is connected to, right here, this one, pin number 6. Okay, and so that's all those LEDs, and then we have the RGB LED over here, and then we have 100 ohm resistors for each of the LEDs anodes, and then the cathode is grounded from through there, that wire, into this negative column again, that's grounded to pin here, and each of the LED pins are connected to 5, 4, and 3 pins. See there. And then you can see when it's the blue LED lights up, the blue RGB lights up. When it's red, the red LED lights up. When it's green, the green LED lights up, and when it's yellow, the yellow RGB LED lights up. So, see, and it's random also.